All right, y'all. In this video, I want to walk you through the first algorithm we have for generating edits. It's not a great algorithm. I'm going to have you write it on your own, but it's sort of our first attempt, right? Just like to, get our feet wet. So let's define some algorithms that compute edits from one strand to another. That's what we're going to do here. The simplest one we're going to do is a very, very simple algorithm. I call it the delete add edit. Here's the idea. You say it in one sentence. To go from a source strand to a target strand, just delete everything in source and then add everything in target. This is like the from scratch edit algorithm. Okay. It's not going to be minimal. There's no way. We've already seen that, to go from DNA source to DNA target 1, it's just, you can do it with cost 1 using a single substitute. So, there's no way this algorithm is good, right? It's not going to produce minimal edits, which is important for us to be able to talk about distance, right? That's how we're going to do the measurement. Uh, but fine, it's a place to start, right? We need to figure out how this all works, and this will be a nice warm up. So the way we're going to do it is we're going to define it in 3 parts. So we're going to define a function delete edit that just produces deletions for everything in the source strand. We're going to have a function add edit that takes a target strand and produces the correct number of adds with the right bases, and then the delete add edit function will combine the two. Okay, so we have some constraints on your solution. Each one should really only be one line each. And I don't mean a cheaty line that goes on forever. It should be very short. So these are very simple functions. For delete edit and add edit, I want you to use the map function. And then for delete add edit, you should use these 2 other functions. And then you can have other helpers or whatever, but you shouldn't need to really define much else, right? Between delete edit and add edit and other functions we've already defined, you have everything you need to write delete add edit. Okay, let's do an example of what the output ought to be. The expected delete edit for target 1. What do we expect to have happen? Well, if it's delete and then add, and we're going from source to target 1, we should have something like, well, delete the G, delete the C, delete the A, delete the T, right? That accounts for these 4. Okay, now we need to add the things that are in DNA target 1. So, okay, add the T, add the C, add the A, add the T. This is what I expect, right? This list is what I would expect as output from this function if you give DNA source, DNA target. Hopefully that sort of gives you a sense of what to do. Maybe you can already see what the map is doing, right? Not so complicated. Good luck. After this, we're going to look at some more interesting algorithms, and then we'll finally get to the real Levenstein algorithm, the real payoff at the end. All right, talk to y'all soon.